Okay, so let's talk about relations and functions. So we're on page 7 in your notes, and that is 2-1. So a relation is just a set of ordered pairs. If you look at number 1 here, this is just a relation. Okay, it's just a set of ordered pairs. Now, we didn't kindergarten dot to dot it. We don't connect the dots. It's just a set of points thrown up there. Think about like a scatter plot or some data or something like that. That's just a relation. The domain.
Hi.
Good morning. Welcome. You're here. You're good. We're on 2-1. So the domain is the set of all the x coordinates. Excuse me, start over. The first coordinates, which are the x's. Sometimes you'll hear that called the independent variable. Switch to this one. The range is the set of all second coordinates or the y's. The dependent variable. A function is a relation where each element of the domain is paired with exactly one element of the range. Or in easier words, the x's don't repeat. We're on page 7, JJ. There you go. A one-to-one function is where each element of the range is paired with exactly one element of the domain. In this one, the y's don't repeat. Okay, good so far? All right, so let's look at number 1. We just have a set of ordered pairs there in our picture. So it says the relation is, we're just going to list the ordered pairs and order doesn't matter. So -4, 0, -3, 1, 0, -2, 1, 2, and 3, 3. Okay, so it told us at the top the domain are the x's. So we're just going to list the x's. -4, -3, 0, 1, 3. If it repeats, you just have to list it once. So if there were 2 that had a 1, something, we would just write it once. The ranges are the y's, so the y coordinates. So 0, 1, -2, +2, and 3. And then it says, is this relation a function? Does each x go to a unique y? Do the x's repeat? They didn't, right? And each x went to a unique y, so we're going to say yes, it's a function. In fact, we have a handy-dandy test to help us determine if it's a function. It's called the vertical line test. And the vertical line test says if I draw any vertical line and it intersects my graph only once, then the graph is a function. Meaning, no matter where I draw a line, I only touch one point. Okay? So as I draw vertical lines, I'm only going to touch one point. If you can do that, then it's a function. If you touch it more than once, it's not a function, no matter where. Okay? So say I would have had another point down here. I'm just going to throw it in. If that guy were there, this would no longer be a function because as I draw a vertical line, I would touch it twice. Does that make sense? Okay, questions on relations? JJ.
So what do you mean by the x's like don't repeat like on the
Okay, so for example, like if I threw this guy right in here, right? His ordered pair would be 1, -1, right? So I have an x that goes to a y coordinate of, or a x of 1 that goes to a y coordinate of 2, and I have an x of 1 that goes to a y coordinate of -1.
Oh, so all the x's are different.
All the x's are different, yes. Good question. Okay? So if you have one x that has two different y values to it, then it wouldn't be a function. Okay? Okay. So that's, a relation is just a set of ordered pairs. Okay? Think about it as like data. You wanted to see, I don't know, how shoe size relates to height, or you wanted to see how many hours you get to go to the gym when you've been working out, or I mean when you've been working more hours. Does that make sense? So think about it as just like some data points. Okay? Well, the other thing, we can graph our lines and other things. So if we look at number 2, it says graph the relation y equals 3x minus 1, find the domain and the range. Okay, well I gave you a t-table. We don't necessarily need that, right? We could graph lines. So let's use slope-intercept form and just graph this guy. So where am I going to start? What's my intercept? My y-intercept? -1. Okay, so I'm going to start at -1. Then what's my slope? 3, right? And then my slope really means 3 over 1. So I'm going to go up 3, right 1, and if you go to the right, you're always right. 1, 2, 3 to the right. 1, 2, 3 to the right. If it's negative, we would have gone down and to the right. Okay, so here we go. Really mad skills at drawing a straight line. Ah! Okay, did it. Now, if you needed your t-table, we could have filled in our t-table, right? We used the point -1 or 0, -1. We used the point 1, 2. We used the point 3, or 2, 5. Does that make sense? We could use our t-table if we wanted, but are those the only 3 points on that line? No, how many points are on a line? Infinite number of points, right? So I could sit here and I could list out my domain and say, okay, it's 0, it's 1, it's 2, it's 3, but it's also like 1.1, 1.01, 1.0001, you know? So is there any value that I could not put into this function? Think about when we were talking about our special ors yesterday. Remember when we talked about our special ors? And if it included everything, what did we call that guy? Anybody remember? It's tricky, I know. All real numbers. There's not a number I can't put in for x where I don't get something out. Okay? So my domain is all real numbers. Yes, I plotted those points to make my life easier, but those aren't just the only points on there. In fact, my domain is my x-coordinates, right? If I look left to right, do I see my graph? Will he go forever in the negative direction? Yeah. If I look to, well, that was the left. Sorry. If I look to the right now, does my graph go forever in the positive direction? Yes, he will. Okay, so eventually he will touch every x value. So my domain is all real numbers. Okay, how about my range? My ranges are my y values. Is there any number I couldn't get out of this guy?
No.
No. So he's also all real numbers. In fact, every line, as long as it's not horizontal or vertical, the domain and the range will be all real numbers. All non-vertical and non-horizontal lines will have domain and range of all real numbers. So as long as my line isn't straight up and down or horizontal, the domain and the range will always be all real numbers. Is this guy a function? Yeah, it is. No matter where I draw a vertical line, it will only touch it once. So it passes the vertical line test. No matter where I draw it, I will only cross my graph once. You could think about if you had a ruler. I'm only touching my graph once. Okay, questions on that one? Okay, look at number 3. The nice thing about number 2 is that it was in a form we recognized, right? Y equals mx plus b. Do we recognize the form for number 3?
Yes.
Yeah, what is it? What do you think?
Well, I don't know what it is.
But we recognize it. We could graph it, right? Okay, maybe we should use our t-table. What do you think? I think that's probably a good idea. Let's just pick some numbers and see what happens to our graph. Now, when we do that, because this guy is in x equals form, let's pick the y values so that we don't have to do a whole lot of rearranging. So I'm going to pick things like -1, 0, 1, 2. So let's just see what happens. So if I plug -1 into this guy, what's -1? Oh, you can't see it, I'm sorry. -1 squared plus 1.
2.
Yeah, that guy becomes 1 plus 1, right? So that guy's 2. All right, if we plug in 0. 0 squared plus 1. 1. What if we plug in 1? 1 squared plus 1. 2. How about 2? 2 squared plus 1. 5, right? 4 plus 1 is 5. Okay, what do you notice before we even graph this guy? 2's on there twice, right? We have an x that repeats. So is this guy going to be a function when we graph it? No, he's certainly not. Okay, let's see what happens. So I'm going to go to 2, and then I go to negative 1. 1, comma 0. I go to 2, and now I go to positive 1. And then 5 is at 2. This guy's actually, if we would have done negative 2, we'd get a sideways parabola, which is, I gotta zoom out so you can see it. Oh, there you go. Okay, so we determined this guy is not a function. Okay, we looked at our t-table over here. Remember, that's just a sampling of the points that are on my graph. Really, it's made up of an infinite number of points. So we've determined this guy is not a function for 2 reasons. My x's repeat in my table, but if you look at your vertical line test, the only place it only touches it once is right there on that vertex. Otherwise, no matter where I draw my line, it touches it at least twice or twice. So it fails the vertical line test and the x's repeat. Okay, now let's talk about the domain. These guys are the x's. So we had some up here, but remember, that's just a sampling of the infinite number of points. So we're looking left to right. Do you see your graph over there? No, so I don't even want to include negative x values because I don't have any negative x values. Where does my graph actually start? At 1, right? And it touches 1. So if I'm looking left to right, it starts at 1 with the x values and it gets bigger. So x is greater than or equal to 1. Okay, remember those are the x's. The ranges. Now we're looking up and down. So I'm going to check to see, do I see my graph? Yeah. Will he extend forever in the negative direction? Yeah, because it's a parabola. It gets wider and wider and wider. How about that guy? Yeah, he gets wider and wider and wider too. Okay? So just like a line, sometimes we can have all real numbers. So my range here is all real numbers. Questions on any of that? How does it fail the vertical line test, Colden? Anytime I draw a vertical line. So if I were to draw a vertical line right here, I touch my graph there and there. The vertical line test says I can only touch it once. No matter where I draw my line, I can only touch my graph once. The only place where I draw it and it touches it once is right there on the vertex. But no matter, it has to do it the whole way. So no matter elsewhere I graph it, it touches it twice. Okay, any other questions? Okay, down at the bottom, we're going to talk about function notation. So if you see this guy right here, f of x, or you see h of x, sometimes you'll see g of x. This notation right here is telling you that it's a function. If you were to graph it, it'll pass the vertical line test. Okay? That's function notation. It's a fancy way of saying y. Okay? But it says, yes, it'll pass the vertical line test and all of that fun jazz. Like I said, it's a fancy way of writing y. Okay? So what this guy right here says is I want to know what my graph is doing when y is equal to -2. Or sorry, when x is equal to -2. I want to know my function value when x is -2. Okay, so if you notice, I was given two different functions. So this tells me to go to my f function, and everywhere I see an x, I'm going to replace it with -2. And I'm going to replace it inside parentheses. Now, think about all you're doing is simplifying. Just like up here, when we plugged it in, all we did was simplify, right? We're not going to do anything to the right-hand side. This is your do not cross line. Okay, you don't do anything with the left-hand side, you're just simplifying the right-hand side. So I'm going to take -2 and I'm going to raise it to the third power. Be careful because I'm taking a -2. Alright, so if you want to use your calculator, you certainly may. You all know how to get to a power of 3. You're going to use your caret. It's right there, above the division. If you're using your graphing calculator, it'll stay up there, so make sure you arrow over out of it. So, -2 to the third power. -2 times -2 times -2. -8. And then I'm going to subtract 3 more. If you want to do it all at once in your calculator, that's perfectly fine. But we should get -11. Now, I want to show you that on the calculator so that you can see the table. So let me plug it into the calculator so you can see. So, that guy right there is a graph of this function f of x. X to the third minus 3. When I go to the table, I should see the ordered pair -2, -11, which we can kind of see on our graph. At -2, it's all the way down here. Alright, so I'm going to go look at the graph, the table. And there you go. At -2, I'm at -11. Okay, so this says, what is my function? What is my graph doing at -2? Its other ordered pair is -11. Okay, questions on that? So part B says, what is my h function doing at 1.6? Okay, well, I'm going to replace everywhere I see an x with 1.6. The cool thing about your calculator is it knows order of operations. So, as long as you use enough parentheses, I don't mind if you just plug this into your calculator. Okay? Now, if you don't use enough parentheses and you don't type it in correctly and you just vomit a number on your paper, that's wrong. Okay? So you have to be smarter than your calculator. But if you want to type this guy just into your calculator, you certainly may. If you feel comfortable and you want to write out all the steps, you certainly may do that too. I'm okay saving time. Did you get negative 6.732? Do you notice we haven't done anything? We haven't crossed the equal sign. We didn't do anything with this number over here. Okay, all you're doing is simplifying the right-hand side. Questions? What do you notice about letter C?
Not a variable.
It's got a variable with it. So, we're going to do the same thing. However, we call this an expression. When I put an expression in, I get an expression out. Remember in elementary school when they made you those little box things and they're like in and then out, right? Remember those things? That's exactly what we're still doing. Okay? Except for I'm not drawing you a box with a funnel and a funnel going out. Okay? You're still doing that. That's why they make you do it. So, here we go. We're going to put 2t into my f function everywhere I see an x. 2t, and I'm putting it in parentheses. Okay? You don't have to pay for them. They're free. Use parentheses all day long. The more the better. And now I just have to simplify that, just like I was doing before, except for we're going to be left with a t at the end. And that's okay. So when I'm going to cube this guy, I'm going to go 2t times 2t times 2t. Well, 2 times 2 times 2 we just decided was 8. And t times t times t is t to the third. And I don't have anything to combine with that 3. So I get 8t minus 3. So when you put a variable in, you get a variable out. When you put a number in, you get a number out. Okay? Questions?